Okay, good morning. Welcome to
SuperMath number 47.
SuperMath 47. Today we learned about Pythagorean theorem.
Yep.
Were you stunned?
Yep.
So the very first example is a famous proof of the Pythagorean theorem. So I thought we would do it for a movie today. And we're going to prove that in a right triangle, a squared plus b squared is c squared. The side of the the two legs. The sum of the squares of the two legs is the square of the hypotenuse. Can't talk this morning. So step one in proving this was proving that a squared equals c times d. How do we do that?
Well, I think we're going to have some similar triangles.
Okay.
So I'm going to label this W, X, Y, and Z.
Okay.
So I'm going to call this an angle 1, this angle 2. This is angle 1 because it's 90 minus angle 2, which is angle 1.
Okay.
That forces that to be angle 2.
All right.
So now that we have this, we need A. So I'm going to use triangle WZY.
WZY. Okay.
Since we have an A and a D, and now we need a C and an A. So we know this is similar to triangle. Let's see, it would be X, then WY. WZY. Oh, I know. It's X. Where'd that eraser go?
I don't know. Use your hand or use your shirt. I'll find one.
Okay, so it's going to be X, Z, W. There.
Okay. There we go. XCW. Oh, the chair was on top of the eraser. Okay.
So I'm going to make a ratio that's going to be short side to hypotenuse.
Okay.
So D to A equals A to C.
Alright, so we've got this small triangle here that you labeled WZY. And so Y is the right angle.
Yep.
And you said that's the same as XZW. Okay, W is the right angle. The first one in your triangle here was W, that's angle 2. First one here is X, angle 2. Okay, so good. So this little triangle, WZY, is similar to the big triangle XZW. And that tells us that D over A is A over C. Okay, awesome.
So when we cross multiply a little bit, we can get C times D is A squared.
Okay, it's not equals there.
Yeah.
Okay, C times D is A squared. Very good. We won't go through the math here, but we can do a same thing with this triangle, WYX.
And the big triangle.
And the big triangle, and get B squared equals, not B squared, oh yeah, B squared equals C times E.
So
you can imagine A squared is D times C from this triangle. Same idea, so it's B squared is C times E in that triangle. And how does that help us prove our theorem?
So I'm going to add these two equations together. So we get A squared plus B squared is CD plus CE. And now I'm going to factor C out of this side. A squared plus B squared is D plus E times C.
Okay.
But D plus E is C. So if A squared plus B squared is indeed C squared.
High five. Good job. This is a very important proof, and it's also an instructive proof because you learn something else that this is easy to remember.
Yeah.
A squared plus B squared equals C squared. But you also learn that when you drop the perpendicular to the hypotenuse from the base, A squared is that distance times that. So that's also very useful. And it just comes from some simple ratios. Okay, awesome. Good job. Proof of the Pythagorean theorem. There you go. That is something brand new that you learned today.